This is Darren Pulsipher, Chief Solution Architect, author, and most importantly, your host.
And welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Zero Trust and 5G Security with special guests Leland Brown, Ken Urquhart, and Yazz Krdzalic.
All right, team, welcome to the show.
Hey,
thank you.
Darren, how's it going?
It's going great. Leland, welcome back to the show. And Yazz and Ken, welcome to the show. So Leland, my whole posse, I don't know, do I call them a posse? I don't know what to call it. Right. They know you, Leland. You are our 5G advanced comms expert, but Yazz and Ken, they don't know you. So Yazz, can you tell us a little bit about yourself, your background, just so my audience knows who they're talking to?
Sure. Yeah, I'd be happy to. Again, thanks for having me. Honored to be here with you all talking about all things 5G. So Yazz Krdzalic, VP of Marketing at Trenton Systems, been in the industry for about 7 years now, doing all things hardware. So all things hardware for us means high performance computing. That's edge computers, servers, small form factors, boards, and themselves. We're here based in Atlanta, Georgia, and we've been doing this for a little over 35 years now. And so I'm happy to discuss and bring our expertise to the 5G and tactical comms equation.
Oh, that's awesome. And then Ken, you come from a completely different background. You come from Zscaler. Tell us why you're involved in this and what's your background?
Yeah, so I'm a physicist who sauntered vaguely into IT career. I have been involved in telco for a very long time. I've also been involved in cybersecurity. Zscaler redo Zero Trust, which is the new paradigm for cybersecurity compared to the old firewall and VPN world. Lets you operate securely in compromised environments. Therefore, it's great interest to the telco community, great interest to the government agencies, and great interest to global corporations. I've been very pleased with the uptake, and I'm very glad to be working with Leland and with Yazz on such an important topic of securing telco infrastructure for private use and for military use.
Yeah, so this is a whole new thing, because when Leland and I have talked about 5G, it's game changing. But no doubt, it's software defined, so a lot more flexibility. But we've talked theoretically. We've talked, hey, there's public 5G that's working, but private 5G and making it real with O-RAN and FlexRAN and all the RAN stuff that we talked about. You guys have all come together and made it something that is actually I can go out and get now. So, Leland, tell us how we got to this point.
Yeah, well, so, we've all, and we talked in the past, Darren, as to how the Department of Defense and the commercial side of the track around 5G and various cellular technologies over the past, 10 years or so have been trying to find a way to ignite the capability of the warfighter on the battle space, utilizing commercial architectures that can be leveraged over for military use cases. And 5G has been a focus point for this, not necessarily because of the throughput and latency, I would say, enhancements over 4G is really around the infrastructure being software defined, virtual, and capable of being really strategized and placed in front of various military use cases on a common architecture. So over the years, working with Yazz and working with Ken closely, we've always had this thought and process saying, hey, we honestly believe, along with Intel, that we can make this happen. And why not? So let's just go forward with it. So it's really a strategic partnership, which is really designed in terms of the goal, is to build this capability together, to fast track the execution of this, develop an O-RAN-based integrated advanced comms solution specifically designed to empower the modern warfighter. That's the goal. Okay.
So what held us up before in the past, Leland or Yazz, any of you guys? What held us up before in the past on making this a reality? Because O-RAN's been around a while. right?
The
So
idea of ORAN's been around a
Right.
while. Actual
okay,
execution,
all
come on.
right.
It's look, it's lovely to go out and mark and say this guy's going to be fantastic when you finally get it.
Right.
It's here now. It was not simple. It represented. I mean, Leland, I know you can talk more eloquently, but for me, the whole point is how complicated it was to get the pieces to work together, because it represented a re-engineering of how we thought about radio technology. Just like the we refactored how the software and hardware came together. We tried to replace custom hardware with off the shelf and do as much as we can in software. And that represented a fundamental change to how telcos and telco equipment suppliers have been providing solutions to military, government, and the commercial sector.
Yeah. And
Well, yes, this is where you fit in, right? I mean, you guys
Exactly.
have the hardware, right?
Yep. And I was about to say, early on, I coined this term lonely island approach. And that's really kind of to answer your question directly. Why was this so hard? Because you've had multiple entities that had the skill set and they had their own islands. They had their own set of problems, and that's all they focused on. So the three entities here strategically got together, because if you really look at the entire solution and the collective team, what do you have? You have these scalable, flexible hardware, edge ready, meaning it can work on-prem, in the cloud, and at the edge. Now you've got the software that enables the RANs and the cores. Now this ORAN compliance. And then with Zscaler, you come in and you zero trust protect the whole thing. So we strategically formed this team to answer all three pain points and to remove this lonely island approach and say, hey, why don't we pick common ground here and rebuild this architecture from ground up so that it's easy for military deployments, it's easy for the telcos, and the hardware, software, and security scales and flexes with the different use cases. And that's why it was so difficult in the past.
So do you think that it culturally, because telco is very operational technology centric, right? Which OT guys tend to focus on custom hardware and software stacks.
Mm-hmm.
Do you think that this cultural shift from a more IT centric, more flexible, more is what slowed it down? Because we've talked about this for a long time.
Yep.
Do you think that's what slowed it down, and that you guys just finally all came together and said, "Screw it, we're moving forward with"?
I'm glad you said it the way you did. That's exactly what it's the convergence of OT and IT, the convergence of hardware and software, the convergence of, I would say what used to work now, security, to true zero trust security. And it's that cataclysm of all these different thought processes saying, you know what, to hell with all this lonely island, you have your problems, I have mine, let's go through the rigmarole. No, we're all getting together to solve this for the customer.
Yeah.
Exactly.
So technically, well, just a second, just say, so culturally you guys pierced the veil. Okay, great. Technically, because everyone, all the OT guys and the IT guys, I've talked to them a lot. That's what my PhD dissertation is on, is the convergence of OT and IT cybersecurity best practices.
That's awesome.
And they don't talk the same language at all, not even close. So you guys pierce that veil, but they all tell me one thing: technically, it's not feasible. What technical barriers did you guys bump into, if any, when you started, pushing all this stuff together?
Yeah, it's a problem to solve. We talk about, well, we don't know this, we can't do that. It's like, you think about it and you solve it. You got customers saying, I don't know what to do. Leland, Yazz, and I were talking. It's like, yeah, so many 5G cores are available. The big switching machine behind the scenes.
Right. Yeah.
And they go, great. And the customers go, yeah, I can get a core. Fantastic. Where's my antennas? You're like, yeah. What band? What band? Yeah. What band do you want to operate in?
So they were still talking in the old. They're still talking the old way.
It's the fact that there's all these bits and pieces, and it was always somebody else's problem. It was always the customer's problem to pull the pieces together, just like 3GPP, 5G spec, the ORAN spec. At a fundamental level, there's no security required because that's left
Right.
as an exercise for the implementer. So then it goes, all right, here's how the technology works. Fantastic. You do the security. Do I? Yeah. And if you're doing it privately, the telcos, they take care of their security. But if you're going to do it privately, it's on you, bud. And I go, what? Yeah, congratulations. You're now a telco. But isn't this like Wi-Fi? I just buy some stuff and stick Ethernet cables into them? No, it's a little more complicated than that.
But
And
it
Darren
should
mentioned
be
the
what
FCC
you guys
has to
would.
get involved.
Yeah, what you guys came across with, and Leland's taught me this,
Yeah.
is it should be simple
Yes.
and
It should be
flexible.
simple.
Right.
Yeah, it should be simple. And let's think about this, Darren. Let's think about what drives technology development. It's all around business, right? And what does a business model within the commercial side of the track look as relative to the mission requirements of the military? Okay. Of course, this team is mission focused, where we're talking about private 5G network deployments. There's a lot of drivers on the commercial side, and in terms of the business, that'll keep that steady state going down the same track. That would have never met the requirements of mission, requirements of military. Let's just think about this. One key thing: most of your 5G private network deployments on the commercial side are static, meaning they're sitting still.
Yeah.
On the
Yeah.
military side, this is mobile. We're talking about going to edge points, forward operating bases, tactical operating centers,
Search and rescue. I can see it in state government too, right? Search and rescue, police, fire.
Exactly. So those same functional blocks, those same functional technology blocks that you would see on the commercial track, have to be implemented very different on the military and defense use case focused side. Who's willing to take that stance to go forward on that, invest, find the teams to put that into play, and that's what we saw. We saw
That's
the
what you
gap.
guys
We saw
did.
exactly right.
I'm going to steal Leland's thunder here a little bit. I like
Go for it, yes.
always uses is a common architecture. And this common architecture you build on to enable what? Operational efficiency. Where? Anywhere. You shouldn't have to, just because you change a use case, now the whole equation changes. And like Ken said, oh, well, welcome. You just became a CSP. Congrats.
Yeah.
You figure it out. No, it's not supposed to be that. If we are building the easy button, let's make it easy across the board. Yes, we're going to have some bumps that we have to figure out, but where there's a problem, there's an opportunity. So that's the approach we took to this entire solution. And we said, okay, let's keep the goal essentially, almost if everybody agrees here, was how many problems can we unravel to go solve? And that's what the collaborative effort has been. That's what we've been doing for the past few months to get to this final solution.
Have you found this final solution that you guys come up with? Is it generic enough that it can be used in most use cases?
Yep.
Or is there adaptation that's needed to deploy it everywhere? Or can I just take this thing and use it and it works almost 90% of
That was
all
the
use cases
goal.
that are out there?
That was the goal originally, which is customers just say, can you not sell me something I just plug in and I can stick a SIM in a phone and it connects and it works and I can
And
trade
it connects.
data.
Yeah.
That's where, the three of us sort of said, it's got to be that simple.
Right.
We'll take on the complexity of integration and the security and the radio working with the core, because that was always left as an exercise. You buy all the pieces and you have to do your own integration and you've never experienced it before. And we just said, there's no need for that. We all know how to do this. So why don't we just get together and do it? And that resulted in the product that we demonstrated at the Intel Public Sector Summit late last year. Like, here it is. It's a SKU. You can buy it now.
You just buy
Take
it.
home and start using it. Stick it on the Jeep and start using it.
Yep.
I love the story because you brought a hardware vendor, a systems integrator, Capgemini, which Leland now works at, and security, which is Zscaler, Trenton Systems, the hardware, and Intel providing the chips inside, all came together and actually created a SKU, which is unheard of, frankly.
Well,
right? I can buy a turnkey solution. This is awesome.
It's so obvious and yet everyone's running around not doing it. It's like, consciously not doing it. And it's like, does anyone listen to the customer? I know the three of us sure did.
And that's
exactly.
you mentioned Intel on the chipset side, but it's also far more than that. We're actively working to even optimize the existing solution, where we are simplifying it, making it smaller, making it more rugged, making it more agile, scalable. That's like what Ken just said. That's what the customer wants. Hello, like how many times can a customer say one thing, and you hear it on the military front, commercial front, industrial, enterprise, whatever sector you want to look at. The use case changes, but the underlying pain point remains the same.
The same, easy. They want it easy.
Correct. And I always think of myself, way back in the day, I get a brand new phone. I have to walk into a store and they give me a SIM card. Now imagine if I walked away and they said, all right, well, you have the SIM card. Good luck figuring out what antenna you have to figure out. And every time you move a city, you have to call another company. And it's just not, the user experience is not there.
I like that you said user experience, because there's a thing that happened just this last year about user experience, and that's generative AI. Chat GPT comes out with a chat interface. I don't have to train a model, and it explodes the world.
Yep.
Because of ease of use. So if you guys make it that easy to use, why wouldn't I stand my own private 5G up everywhere? I mean, this makes perfect sense to me.
Yeah.
Right.
Go ahead.
Go ahead. Yes, please. No, go ahead. Yes, please.
Okay. So I just had a conversation around this effort. They've had existing infrastructure. It wasn't cutting it anymore. You had more users, more subscribers, more devices. That's the promise of 5G. That's, from, as Leland mentioned, it's not just the throughput, it's everything else. But then you enable it and it's easy. And then you go, oh man, well, now I have the attack surface all of a sudden grew exponentially.
Security. Yeah, the security.
And so we're thinking not just what's the problem and how easy is it, what problem could you run into? And so between the entities that you see here, this solution truly is an all-encompassing turnkey solution that truly touches across major pain points and then digs into the little nitty-gritty details based on your specific use case.
So let's talk a little bit about the zero trust aspect of this, because Leland schooled me on 5G last year and the year before. And I said, oh, 5G is more secure. And he went, nah, it wasn't built into the spec, right? But 6G possibly might have it. There's debate around that, right, Leland? Did I say that right?
No, you actually said it right. One of the key things around the development of 6G is a more secure specification, or let's say security integrated into it. At the same time, there's companies out here that are looking to find ways to provide more security across the RAN stack, the MEC, and the like. And this is where Zscaler and Ken have come in and really provided a really key strategic solution for us to frame this up. So I'm, first of all, happy to have these gentlemen here with me. And as we stated in the past, Darren, we wouldn't have been able to go forward, Intel, Trenton, Zscaler, and especially Cap, without this team. So more than willing to let the stage be held by these two gentlemen. And Ken, please explain to us.
Yeah, I mean, Ken, let's hear, because Yazz said something that scares OT guys like crazy. Attack surface. And I'm no longer behind my Purdue firewall model anymore, because now I've got 5G that's now attached to all my OT stuff. Scary.
Yeah. Well,
how are you protecting us, Ken?
I mean, the thing about why 5G got everyone excited is in the current 4G LTE world, I have, let's say in a square mile, I can have tens of thousands of SIMs in devices, and everything kind of works okay. Some hits on the throughput, hits on the amount of data I can transmit, fine, some sharing, okay. 5G and power consumption in the devices, battery life. 5G said, okay, look, can we boost that like to 1 million devices, 2 million devices, and have
Yeah, why not?
guaranteed amounts of data transfer, guaranteed amounts of speed that doesn't slow down as you add more devices. Oh, and by the way, can we cut the power usage in the antennas so the remote devices can have 10-year batteries attached to them rather than having to be connected to the grid? And you go, oh, yeah, for a battlefield, huge opportunity. Sounds great. And then you say, oh, yeah, we left security as an afterthought. And so you do things like look at the old firewall, VPN, IPsec world. And I know for a lot of people, those aren't going to make much sense. But for cybersecurity people, the world we've been living in since the late 1980s. And I know because I was actually there when universities were the attack surface, and there was this group in East Germany who was just all through the academic system, and we had to toss them out. That stuff's been carried along and augmented, added to, made more complex, made more difficult, made more integration challenges. Zero Trust was brought in about 15 years ago to say, can we just think about a world where I don't have an us versus them? I don't have a digital wall, the firewall between where I am and where the enemy is. That was just the model of military bases. I put up huge fences and I patrol them actively.
Right, yeah, of course. That's how we've done battle for decades.
Yeah, but I will react. And in that metaphor, digitally, it was I will react once the perimeter has been breached, and I will rain down fire on whoever breaches my perimeter. Zero Trust took the approach, let's say there's no perimeter, because it's meaningless. And it's the security model, which is always react. React is also a very expensive proposition in the digital world. It's cheaper, more efficient, and a lot less trouble to stop the attack before it happens. So the idea of how do we do that? Zero Trust has 5 things under it. Is who are you? Just because you're inside, remember, when you were inside a firewall, the assumption was you had a right to be there. So a lot less, if you could breach it and nobody notices, I can move around and do a whole bunch of stuff, and you kind of assume I have a right to do it. With Zero Trust, it's, who are you? And I'm going to challenge you always, everywhere, anywhere. Yeah. I don't care. I'm challenging you.
Right. Trust no one, verify continuously, right?
Verify continuously. Don't trust, verify always. So I got the identity. I know it's you. I don't assume it's you. Second is device. Are you operating on devices you are allowed to operate on? Right. Do they have the security posture they need to have to be here? Which is basically, do you have can you prove to me you need to be where you are when you say you're who you are? So now I got identity and the device down. Then it's like application. Is the application behaving like it should behave? If it's a database, is it behaving like a database, trading data, using protocols for the database? Or is it trying to poke around in the GitHubs? Is it trying to poke around in sensitive targeting systems? Databases shouldn't be doing that in general, especially like say it says I'm the finance database, right, but I'm just poking around in the missile arming system. No, that's not allowed. So then network, everything's encrypted, but inspected. This is critical. Most attacks now focus on encrypted traffic, and most encrypted traffic is not inspected. So if you want a true Zero Trust, you better have a way to break and inspect that's safe, simple, and it's trustworthy, and the military service using it has confidence in that security. Exactly. So, and then finally, that takes us to data. Trust nothing. Check everything going out to make sure nothing good gets out. Check everything coming in to make sure nothing bad gets in. Spyware, malware, ransomware. 5 pillars. That's Zero Trust. Let you operate safely. So when you can't verify, you're in a safe environment.
So how do you apply the Zero Trust pillars? Because we've talked about that on the show quite a few times. How do I implement that in 5G, right? Because 5G, it almost flies in the face of traditional thoughts on zero trust, which is I got to protect every little thing. And now I've just opened it up to 1 million devices on the same 5G network.
So, two aspects. First, you got to make sure the network is secure.
Okay,
That's something telco industry has known how to do. It's something we help.
they do well, right? They've done that for years.
But while you have an assurance the network is safe for a certain value of safe, there's no guarantee your devices or your applications are covered by that security. They're not. So I have transport. With zero trust, it's a way to say, let's treat that network, let's treat that 5G system as a packet transport machine. That's it. And then you overlay security on top of it using principles of zero trust. So today with Zscaler, we have multiple options. We can protect your applications, your equipment, your users on any 5G and antenna combination without having to touch or have any knowledge of the 5G or antenna combination.
Because you're overlaying a network on top of the transport layer.
Which is why for military applications, I can take mixed copper, fiber, 5G, 4G, esoteric waveforms for other packet-based communication systems, satellites, and protect end to end, and I don't have to know which one you're using. So they're free to choose the best combination for the mission.
Right. So what you've done, it's interesting because when we talked about 5G in general and moving to an O-RAN software defined, what you've said now on top of that is to really secure things. I'm gonna have software defined networks on top of this software defined 5G, so that I can create new networks based off of applications instead of network connectivity.
Yeah, it gives you security up to layer 7, meaning I can have a security posture for an app on your PC user equipment, going to a specific cloud-based, edge-based app, and give you one security posture. A different
that
app
decreases
going to a different location for a different purpose can have a completely different security posture. It's that fine-grained.
Yeah, so that completely changes the way I think about security traditionally on these wireless networks, right?
It simplifies it greatly.
Yeah, it simplified it a whole lot. So this makes it easier for me. Let's say I have a search and rescue company, whatever, right? I can get one of these, and with zero trust built in, I don't have to go through the rigmarole of locking down every single bit on the hardware side. I still have to do some of that, right? I have to protect the O-RAN still. But before, I would have to do a lot of monitoring, a lot of all that stuff. With this concept of overlay networking, I've simplified how I need to do that. I only need to monitor at that level, at the application level. I don't really, who cares if people are sending stuff around my network?
Well, the other part, though, is that the instrumentation around zero trust, remember, you're looking at a lot of things.
Yeah.
A lot of data is being collected. You can find patterns that you miss with other solutions. We at Zscaler, with our customer base globally, we process about 5 trillion metadata signals per day.
Wow.
To see zero-day attacks, to see funny behaviors, and to create additional defenses and propagate those to all our customers globally. And remember, the same platform that we have, which is FedRAMP High certified for use by the military, use by government agencies, is what we get the commercial sector. So everyone gets
the high
security. It's not like everybody gets the security at the lowest level in the commercial sector, and then you have to do bolt-ons. Everybody gets the same security.
Yep.
We respect the countries we can't sell to. Yep. That's fine, but we're delivering to the Western world the best quality cybersecurity you can get, integrated in a way you can set it and it integrates itself. No patching. We take care of the patching, we take care of the integration, we take care of making sure the packet flows are optimized, and can give you a bunch of data on how to optimize your networks in exchange.
You guys talked about the easy button, right? This gives me the security aspect, the easy button on the security aspect. I've got Capgemini providing services to help me set it up and get it all, set up. Trenton Systems, what you guys have done is put it on small platforms, ruggedized, right? So now it can really handle forward. Tell us a little bit about what that looks like as far as size goes, because a lot of my customers are going to be worried about swap and things like that.
Yeah, a lot of our customers are worried about swap. That's the one thing that I've been talking about last year around this 5G effort. The moment you mentioned the IES solution, which initially started as a 19-inch rack server for high-performance computing at the edge for tactical deployments in not-so-friendly environments. And Ken brought up a great point. So with the Zero Trust, it almost doesn't matter. It's the easy button for all things Zero Trust cybersecurity. It scales up or down. With Capgemini, it's the software stack in the middle and all the support around it. It doesn't matter if it flexes up or down. With Trenton Systems, it's the underlying hardware in any way, shape, or form, fit, function, essentially what we're talking about. So do you need high performance computing with all the latest GPU technologies for AI inferencing at the edge? And now you have to layer on top 5G? Sure, we can do that. Here's that inside of a transit case. Sure. Do you need it as a man-packable solution for, let's say, certain scenarios like the first responder example you used? That could be a scenario. For military deployments, it could be a platoon or a brigade or somebody going out there, put it on a vehicle, put it on a person. They all still need to communicate. So when I say hardware flexibility and scalability, that means the physical, the tangible hardware. How does it look like? What can it be? So for Trenton Systems, yes, we design, manufacture, assemble, test, vet, certify, support everything out of the USA. That's a key differentiator because we control the supply chain. That means these components are vetted inside of a secure supply chain. We are able to design around any end of life or shortage issues. Therefore, we're able to tweak it in any way, shape, or form. And we have access all the way down to the BIOS level. Talk about security. You have Zero Trust, but you also have securities within the system.
Of the hardware itself.
Correct, of the hardware itself. And now you take the Intel story, you put in the next gen Xeon scalable processors into this solution, and what do you get now? All of a sudden, you have all these other technologies and security and cryptography and encryptions that are available to not just speed up the performance and enhance it, operational efficiency, you're also protecting, again, how this data communicates. And our boards, we've designed them in a way that this communication, I mean, we all talk about data, but for our engineers that are actually designing these systems, they're looking at signals, electrical signals. How fast can they go from point A to point B? And there are bad actors that are even focusing on
intercepting those.
Those. So what do we do about that? How do you handle top security data versus secure data for them not to overlap? So these systems, we call it's essentially hardware-based security. So you have hardware-based security on top of hardware that's scalable and flexible, fused with Intel technologies that bring performance, throughput, and encryption and security with it. And you throw in the Capgemini story on top of that with the flexibility and Zero Trust. Essentially,
it's beautiful.
It's truly
because you guys build security in at the base.
At the base, we say at the board level.
It's not glommed on the side.
Hardware and software. That's the beauty of it. You can't build systems that deliver on the warfighter's mission unless you know that your hardware is not going to be flaky on you, that the hardware is going to perform in the most demanding of situations, and you've got digital security. Those are table stakes. Yeah. And then you can build almost anything on top of that.
Okay, you guys convinced me. I need to buy one for home. Leland knows this about me. I have 10 kids. The family is now, we're up to 22.
All right.
In the family now. I need my own private 5G just to keep everyone connected. And believe me, it can be like a war zone sometimes when we're all together. So, where do people get more information on how to get access to this product? Is it through Capgemini, through Trenton, or through Zscaler or Intel?
All of us.
Who do they call? Who do they call?
D, all of the above. And
all the above.
Correct. And there's enough information between the entities here that we can chime in on. And again, there's not a week, sometimes a day that goes by that we don't talk to one another, where we have ideas on how to improve it and how to make it better. We hear something from a customer and they want it. How can they get their hands on it? So we're all subject matter experts in our own swim lanes, but we are a force.
No, you guys have talked in each other's swim lanes pretty good. You guys understand each other very well.
I've learned a thing or two about
sometimes ideas
core and security.
Yeah, of course. So you guys, you'll give me the link if you're listening to the show. Just go on to our website, embracingdigital.org. I'll have links on there where you guys can get access to additional information about this. Guys, it's been wonderful talking to you. I learned more today. Every time I talk to you guys, I learn more. So thanks again for coming on the show.
Of course.
Thank you.
Thank you.
Appreciate it.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.